This problem involves calculating the parameters for a rating curve for a weir. We're given that this function, this power function here, is the one that we want to use, and so the problem then becomes determining the parameters a1 and a2. So we can do this by taking the log transform. We apply the natural log to both sides, and this equation becomes this equation. And so by inspection, we can tell that this equation would plot as a straight line if we use the natural log of q as a function of the natural log of h. a2 then is the slope, the natural log of a1 is the intercept. So we go down here to the data, and we know from the log transform that we're going to need the natural log of h and the natural log of q. So we simply calculate those using the calculator. And now we're going to plot it up, and we need to determine the axis, basically the range of the axes, so that we can have this plot and form a fairly reasonable slope. So what I did was to pick this range along x to go from 0 to zero point 0.7. I noticed 0.69 was the largest value, and I'm going to want the intercept. So and it was close to 0, so I thought I would just include 0. Sometimes if 0 is a long way away, it's not really worth including, and you would do the plot and then have to extrapolate to get to 0 for the intercept. But in this case, we can include it. And then the y-axis is going from 2.8 to 4.3. So I looked at the ticks that I had, and I thought, well, I can go from 2.7 to 4.2, where each tick counts as 0.2. So I did that, and I labeled it, and then I went and plotted the points, and notice that I use the symbol X surrounded with a circle around it that locates the points, and it also makes them easy to see. So they're accurately located, and then when I draw this line through them, I can see that this line goes through these points that are really quite accurately located. Okay, so that is the graphical part. I also label this as the natural log of h and the natural log of q, just to be clear. And now the next step will be to do the calculations. So I've tried to lay these out in a clear way. The natural log of a1 is 2.34, and I did that by extrapolating out here to 0. And I didn't really have enough. I didn't actually locate the scale quite right. I probably should have slid all these up a little bit, but I didn't really anticipate that when I plotted things up. So I had to go and measure down here and extend the scale, and I get that the intercept is 2.34, and that puts A1 as 10.4. That's equal to, yeah, actually what I should have done here is labeled A1 as equal to e to the 2.34, and that equals 10.4. That would have been clearer. And I didn't put the units here, but I will do that later down here when I have the final result. A2 is the slope, and I do that by I've marked off how I did that here. There's the change in x and the change in y, and so I get those values, come up with 2.58 in the calculations, and I just rounded that to 2.6. Okay, so these are the calculations that I've done, and then for my result, I rewrite the equation just so that it's clear what I'm doing, and then I give the resulting parameters. I write the parameter, I give the numerical result, and I give the units that go along with it. So I don't have the units up here, but I'm sure to include them here with my result. And then A2 is 2.6, and probably would be a good idea to write dimensionless right here, just to be clear to the person that's looking at this problem that I recognize what the units are and that they are in fact, that number is in fact dimensionless. And so then I do a check. I take this equation and put in the parameters, 10.4 and 2.6, and substitute in 1.6, which is this term right here. Do the calculation, and I get 35.3. The result is 35.0, and so that's quite close, and it checks out. Okay, so what I've got here then is this problem. It's clearly plotted. It's clear what's going on. I can see the points. I can see the line. The calculations are fairly easy to follow here. It's clear what the results are. The result has the parameters and the units. And I would add, I think, dimensionless here. I have a check that's written out here that's clear. So even though the space is quite limited, there is enough space to show how this problem is done. It would also be possible, of course, to take these calculations that are shown here and put them on another piece of paper where you have a little more room and can spread out. But however you do it, you want to make sure that the methods that you use are clearly shown, and when you come up with a result, that's clearly stated and it's easy to identify. Those are some very important steps for coming up with a successful completion of the problem.